Welcome back to my channel. Today we're gonna study odd and even functions. By the end of this lesson, you will be able to tell whether a function is odd, even, or neither. We will also discuss that for relations in general, not just for functions. A function is considered odd if f of negative x equals negative f of x. It means that when I substitute negative x in the function, I get the negative of the function. But for even functions, when I substitute negative x, I get the same value of the function for that x. When f of negative x is not equal to f of x or negative f of x, then the function is not odd and not even. It's easier to start with even functions. Firstly, we will learn how to tell if a function is even without graphing. Then we will learn how to determine that from the graph of the function. Firstly, let's substitute negative x here and see if we get the same value of the function or not. F of negative x equals negative x squared. This is equal to x squared because when you square a negative number, you always get a positive answer. If we try this for a number, let's say that x equals 2, for example. F of 2 equals 2 squared, and that's 4. F of negative 2 is negative 2 squared, and that's 4 again. So f of 2 and f of negative 2 are equal. Then we say that the function is even. Another way to tell if the function is even or not is by graphing the function. The graph of this function is symmetric about the y-axis. If the function is symmetric about the y-axis, then the function is even. If I put a mirror on the y-axis, I see that the right part is a reflection of the left part and the left part is a reflection of the right part. So it is symmetric about the y-axis. It means that the right part and the left part are similar. This is an example of an odd function. If I substitute negative x in the function, I get negative x cubed. And when you cube any negative number, the answer is negative. So this is negative x cubed. This is f of x, so f of negative x is equal to negative f of x. Let's try that for a number. Let's say again that x equals 2. Then f of 2 equals 2 cubed, which is 8. F of negative 2 equals negative 8, which is negative 2 cubed. This means that the function is odd because f of negative 2 is negative f of 2. When we substituted the negative number, we got the same answer but negative. Also, we can determine if the function is odd or not by graphing the function. Odd functions are symmetric about the origin. So the first quadrant is like the third quadrant, or the second quadrant is like the fourth quadrant. So the function here is symmetric about the origin. And when the function is symmetric about the origin, it means that the function is odd. Now, what about this function, x cubed plus x squared? Firstly, if we graph this function, we see that it's not symmetric about the y-axis. The right part and the left part are not the same. So it's not even. And also, it's not symmetric about the origin. So again, it's not odd. We can tell that a function is neither even nor odd by substituting a negative number and checking if it's the same or not. F of 2, let's say, equals 2 cubed plus 2 squared. This is 8 plus 4, which is 12. F of negative 2, if we get 12 again, then it's an even function. If we get negative 12, it's an odd function. Let's see what value we get when we substitute negative 2. This is negative 2 cubed plus negative 2 squared. This is negative 8 and this is positive 4, because when you square a number you get a positive answer, whatever the sign of the number is. Look at the values here. The first one became negative while the second one stayed the same. This is negative 4. Then I can tell that the function is not even and not odd. What about a function like this? F of x equals the absolute value of x. If we graph this function, we get a V shape at the origin. And this graph is symmetric about the y-axis. Now, what about substituting numbers? Let's say f of 3 now. You can choose any number in the domain of this function. And the domain of this function is all real numbers. So you can choose any number you like. F of 3 is the absolute value of 3, which is 3 again. F of negative 3 is the absolute value of negative 3, and that's 3. F of negative 3 is equal to f of 3. It means that the function is even. What about a rational function? F of x equals 1 over x, for example. F of 1 equals 1 over 1, and that's 1. F of negative 1 equals 1 over negative 1, which is negative 1. This is an odd function. If we graph this function, we get a graph somehow like this. And this is symmetric about the origin. So from the graph, again, you can tell if the function is even or odd. What do you think about sinusoidal functions? Like f of x equals sine x and f of x equals cosine x. You can try it for any angle in the domain of sine x, but let's say that x equals pi over 2, for example, which is 90 degrees. This is in radian, and this is equal to 90 degrees. Sine pi over 2 equals 1. Sine negative pi over 2 is equal to negative 1. Negative pi over 2 is 270 degrees. We can tell that this is an odd function. What about cosine x? Let's try it for x equals pi radian. This is 180 degrees. Cosine pi is equal to negative 1. Again, cosine negative pi is equal to negative 1. Actually, this is pi, and this is negative pi in the opposite direction. It's 180 again. Because we got the same value, although it's negative, but it's the same value, the same sign and the same value, it means that this function is an even function. Let's try to graph them both on the graphing calculator and see how to tell if they are even or odd. This is the graph of sine x. If you take this portion, for example, to make it simpler, it's symmetric about the origin. So this is an odd function. And this is the graph of cosine x. If you take this portion, you see that it's symmetric about the y-axis, then it is an even function. This is cosine pi over 2, this is cosine pi, and this is cosine negative pi again. In order to understand more how to find if a function is odd or even, we need to solve some more questions. Which of the following functions is neither odd nor even? If you have a set of ordered pairs, you need to look at the values of x and the corresponding y's. Look, the first one is 1 and 2, so f of 1 equals 2. F of 4, the second one, is 7. F of negative 1 is 2. Look at these two values. F of x and f of negative x are both equal to 2. But we need to make sure that it's applicable for the other points we have. Also, f of 0 is 4. F of negative 4 is 7. Look at these two. We can say that this is an even function. So this is not the right answer. Now let's check it for b. F of 1 is 2. Let's just consider the repeated x values. F of 1 and negative 1, f of 4 and negative 4. So f of 1 is 2. F of negative 1 is negative 2. F of 4 is 7, while f of negative 4 is negative 7. So we can say that this function is odd. So again, it's not the right answer. What about c? For c, we need to substitute a number. Let's say f of negative 2, for example, is equal to negative 2 cubed is negative 8 minus 1, this is negative 9. And f of 2 is 8 minus 1, this is 7. It's not even and not odd. Actually, for polynomials, you can use another method to tell if it's an even or an odd function without substituting numbers. By looking at the powers. Here we have x cubed and 1. This power is an odd power. If all the powers are odd, then the function is odd. If all the powers are even, then the function is even. This is x cubed. If this is multiplied by x to the power of 1, then it is an odd function. But here it's multiplied by x to the power of 0 because it's a constant. Then this is x cubed minus 1. We have even and odd powers, so it's not an even function and it's not an odd function. To make sure that you got this idea, I will show you the graph of this function, x cubed minus 1. This is the graph. It's not symmetric about the y-axis and it's not symmetric about the origin. So it's not even and not odd. It's neither. Now we can say that this is the correct answer, C. But let's check it for the other answers to make sure that you understood the idea. Y equals x squared minus 1. This is an even function because this is an even power, it's 2. And here it's x to the power of 0, they are both even. If you want to graph this to check, this is the graph of x squared minus 1. It is an even function because it's symmetric about the y-axis. So we can say that this is even. The last one is an odd function because f of x equals negative x has a power of 1. And this is an odd power. This is an odd function. This is another important question. Which of the following relations are even? So this is applicable also for relations in general, not just for functions. Y equals 2 is a constant function. It's a line at y equals 2. This is y equals 2. It's symmetric about the y-axis, and always when you substitute a positive or a negative number, you get 2. So we can say that this is even. But for such questions, you need to check all the answers because there could be more than one correct answer. So this is the first one. The second one is f of x equals x. This is an odd function as we discussed before. This is a linear function. It passes through the 0. And here its power is 1. It's an odd power. The last one is the graph of a circle with radius 1. If you remember the formula of a circle, it's x squared plus y squared equals r squared. This is a circle with its center at the origin. Actually, this is not a function, it's a relation because if you try the vertical line test, it could pass through 2 points, more than 1 point, I mean. So this is not a function, it's a relation. And it's symmetric about the y-axis and about the origin. So it's both even and odd. So we can say that it is even. Then the correct answer is 1 and 3. This is D. I will leave this question for you. You can send the answer to my email or write it down in the comments below. Now this is a new idea. Which of the following relations are both even and odd? As we discussed before, this is a circle with its center at the origin and its radius is 1. So this is both even and odd. The second one is a hyperbola with its center at the origin. So it's both even and odd. If you want to see the graph of the function, it's somehow like this, with its center at the origin. Actually, the hyperbola is usually curved, like two opposite parabolas. But here, because the vertex is at 0, 0, it looks different. The last one is x plus y equals 0. This is a linear function. This is y equals negative x. This is an odd function. We cannot say that it's both even and odd. Then the correct answer is 1 and 2. This is B. This is all for today. In the next lesson, we will study conic sections. Thanks for watching and see you next time.